Good morning, everyone. I hope that you enjoyed yesterday's concert and that you all have your morning coffees or late night coffees. So we will start with our third session, In Search of Perfect Harmony in Musical Thought, Tartini's Theory and Beyond, with our host, Nate SUKLJAN from University of Ljubljana. So Nate studied musicology and history at the Faculty of Arts, University of Ljubljana. As an Erasmus student, he also studied in Regensburg, Germany. He graduated with honors in September 2009, and for his thesis in musicology, Vincenzo Galilei's musical theoretical and musical aesthetical thought, he received the faculty's award. His research focuses on early music history and music theory. In April 2017, he completed his PhD studies with the thesis Giuseppe Tartini's Istituzioni Armoniche and Ancient Music Theory. Since February 2010, he has been a teaching assistant, and since June 2019, assistant professor for musicology at the Department of Musicology, University of Ljubljana. From 2008, he is the secretary of the Slovenian Musicological Society. From 2011 to 2015, he conducted the Wind Orchestra of Koper. And today's presentation is Tartini and the Ancients, Traces of Ancient Music Theory in Tartini-Martini Correspondence.
Thank you very much, Lucia, for this kind introduction. It is, of course, a privilege to speak before so distinguished Tartini scholars. As you can see in the presentation, I'm going to speak about the ancient music theory in Tartini-Martini Correspondence. And as many of you know, through the years, Tartini constructed a really extensive and complex theoretical system, which is quite difficult to fully comprehend, to fully understand in detail. In his correspondence with Martini, he discussed many aspects of this theoretical system, some of them fundamental for his musical theoretical thought. And it is, of course, impossible to go into detail in this presentation, and it would also require a much more extensive study than merely the study of Tartini's letters. Perhaps it can be done for the written paper. So it is my wish now to try to give an outline or a framework also for possible further work. So if we now turn to Tartini-Martini Correspondence, to the actual letters, we can say with no doubt that these letters have an important place within the extant epistolary of Tartini. And by the extant epistolary of Tartini, I mean the letters published in the recent edition of Giorgio Malagò, which will be presented in a special event this afternoon, and the letters published by Luca Del Fra some 15 years ago. The complete index of all these letters is included in the last edition, the edition of Giorgio Malagò. As we have heard yesterday, probably many more letters and other documents connected to Tartini await to be found in archives across Europe, but this is what we have for now and what I have focused on. And to be even more clear, I have only taken into comparison, I'm about to present the letters written by Tartini himself, so not, for example, the answers to these letters. And with this in mind, the numbers are as follows. In 2 editions, there are 196 letters written by Tartini. And the letters he wrote to Martini have by far the largest share. There are 91, which means about 46%. And the next largest group are the letters to Riccati. And compared to those for Martini, there are only 26, about 13%. I have listed the letters to some other participants just for a quick comparison. But actually, all these numbers in their absolute values perhaps don't tell us much, because we don't know how many letters Tartini wrote in the first place. We don't know how many letters are lost, or how many letters may still be waiting in some archive to be found. It is also difficult to say why it was precisely the letters to Martini that came down to us in such a large number. Perhaps because Martini was a historian and he was used he knew how to take care of the documents, or perhaps because of some historical luck or coincidence, as often happens. But on the other hand, I think it is safe to say that in the context of these extant letters, Tartini's letters to Martini are of high importance. Also because the two musicians were exchanging these letters for quite a long time. They range from 1730 to 1769, which is not the case with any of the other correspondents, with the exception, of course, the letters that he wrote to his family. So if we now take a closer look to the letters, we may say that they cover a vast field of various topics. In general, we could divide them into professional and personal, although there are many letters that couldn't be easily classified into one of these groups. The majority of personal letters is concerned with various favors, like that he asks for, or is sending all kinds of goods. You know the content of these letters. He's asking or sending them chocolate, sausages, ready stockings, tobacco, and even money, which shows that he and Martini must have had at least some kind of trustworthy, if not a close relationship. And in professional letters, Tartini writes about students, about teaching, about compositions, about treatises, and for the most part, theoretical issues. And there's quite a lot of these theoretical letters, 39 of them. However, 21 of these are only, I wrote circumstantial, because it means that the theoretical issues are only mentioned and not really discussed. Tartini, for example, is often asking Martini and the mathematician Balbi if they had already read his treatise and discussed individual theoretical issues. Finally, the 18 letters that remain are strictly theoretical, and it is in these letters that the theoretical issues are thoroughly discussed. And it is these letters that interest us the most, because they offer us an insight into Tartini's theoretical thoughts and into the construction of his theoretical system. Okay, so as I have already mentioned, Tartini and Martini corresponded for about 40 years, and it's only natural that during this long period of time, Tartini's theoretical thought developed, and consequently, his theoretical letters to Martini can be classified into one of the three groups. The oldest extant Tartini's letters to Martini can be, so from the beginning of 1730s, belong to the first group. I would name this period as a period of study and of setting the foundations for his system. The next important group of theoretical letters is from the beginning of the 1750s. Here, Tartini reaches kind of a peak of his speculative thinking. His system is practically constructed, and he wants to share his already shaped ideas with other experts. And in the last group of theoretical letters, he at least partly turns away from the pure mathematical calculations and geometry, and moves even closer to ancient philosophy, especially Plato's. And in the center of this these letters of his thought from this time is, of course, Plato's Timaeus. So if we look to these groups of letters from a distance, we could perhaps say that Tartini's construction of a theoretical system was a kind of a guided process that went from the physical towards the metaphysical, even though these two fields were always connected in Tartini's thought. Okay, let us now quickly examine at least the first two groups of letters where the ancient theory is perhaps most clearly adapted. As I have already mentioned, letters from the first group are the oldest extant Tartini's letters to Martini from the beginning of 1730s. I could guess that this was the period during which Tartini was getting more and more acquainted with the ancient music theory. This was perhaps also connected to the fact that he lived and worked in Padua, that was at the time the intellectual center of the Republic of Venice, with one of the oldest European universities, as we all know, that Tartini himself also attended, and where during his studies he must have met other intellectuals. Also, yesterday we have heard already about a circle of Paduan musicians who occupied themselves with music theory as well. So it was a rich environment in Padua. So in this context, questions may be posed about Tartini's sources. So how did he get acquainted with the ancient music theory? Was it during his university studies, or perhaps later? What did he read? Did he study the originals or some later authors? So I have to say that at the moment I don't really have the answer to all these questions. However, one thing seems to be pretty clear, and it is that one of his sources was Zerlino, Giuseppe Zerlino. This was, as you know, later also depicted in the famous portrait of Calcinotto. In this portrait, Tartini is represented on the one side with composition by Corelli, and on the other side with the writings on Zerlino and Plato. And we can imagine which book of Zerlino he read. So Zerlino's influence is clear, for example, in letter number 5. Here Tartini speaks. So when I use the numbering of the letters from this last edition of Giorgia Malagò. So in letter number 5, Tartini speaks about the division of the octave with the help of the harmonic mean. He discusses the Ptolemy syntonic diatonic tuning, the harmonic series, and so on. So these are all topics that Zerlino also puts forward in Instituzione Harmonica. But probably the most important is one of Tartini's and Zerlino's key postulates that clearly shows itself already in these early letters, and it is the natural order of things and the perfection of nature, which can be approached precisely through mathematics and through the order of numbers. This is a completely ancient, completely Pythagorean tradition. As we know from his theoretical treatises, he later built a complex theoretical system on these foundations, and in doing so, he followed the ancient theoretical tradition in the sense that he linked music with the construction, with the order of the world. Actually, he put music in the very center of this natural order, which man can access precisely through music, if one is sensible enough, of course. So therefore, the music is the key to the universal existence, to the ultimate truth of things, to the ultimate knowledge, if you put it this way. On the other hand, already in these first letters, Tartini is also critical towards the ancient system. He says that it is not completely in accordance with nature and order of numbers. He speaks of a kind of a natural scale in which the natural order of numbers would be employed instead of the order in ancient tuning system, which are, in his opinion, not completely in accordance with nature. So in the following years, Tartini obviously devoted himself to an even more profound study, and by the beginning of 1740s, he made some very important discoveries, or at least so he writes in a letter not to Martini but to the mathematician Paolo Battista Balbi, where he says, condotto a mano dalla mia fortunata semplicità di pensare, aiutato infinitamente dalla scienza armonica, in cui sinora niun uomo grande si è degnato internarsi, sebbene in essa solamente vi è la chiave della natura. Ho scoperto molti fenomeni e fisiche dimostrazioni, dalle quali, illuminato e dalla musica portato nella natura fisica universale, ho veduto chiaramente la soluzione di tutte quelle difficoltà che sinora sono insolubili presso gli matematici, e sono tutte le incommensurabili, ridotte mensurabili a misura comune, siano le diagonali, sia la quadratura del circolo, la legge dei gravi, forze, resistenza, eccetera. La natura del continuo, la natura dei centri è, in una parola sola, la misura del uno come uno, cosa che pare contraddittoria, ma che è vera, verissima, perché si tratta di dimostrazioni e di prove fisiche. So he studied more in the 1740s, made some new discoveries, and then approximately 10 years later, his speculative thought, as I have already said, reached a kind of peak, which can be well observed in the second group of letters to Martini. So what happens in this second group of letters? In the beginning of 1751, Tartini informs Martini that he has written a short treatise and that he would like him and Balbi to examine it. And several authors who have previously dealt with these letters were of opinion that the treatise in question was the Trattato di Musica, that was, as you know, actually printed then a few years later. However, during the preparation of this new edition of letters, the treatise in question has been identified as an unedited manuscript 232, kept in the archives of Piran and entitled Quadratura del Circolo. So it is to this manuscript and not to the Trattato that Tartini refers in these letters. And here Tartini brings his speculative considerations to a much higher level. The mathematical operations and discussions are much more complex than those in the ancient and Renaissance treatises on music. And at the beginning, Tartini clearly states his goal. He wants to solve the ancient problem of squaring the circle by the means of music, or to be more precise, by the means of the third tone, a new harmonic phenomena he claims to have discovered. He writes like this: si è scoperto un fenomeno armonico per di cui mezzo si pretende ottenuta la quadratura del circolo non già nel modo comune, ma in modo particolare, che significa molto più, dedotto dalla scienza fisico-armonica di cui presentemente non si ha cognizione. Il fenomeno è questo. Then he describes this phenomenon, the third tone. So he aims to solve this ancient problem with the help of music. For him, algebra and geometry are merely tools that can help him to achieve his goal, when in fact the true central point is the harmonic understanding or harmonic order of the nature. Tartini later, in fact, included a major portion of this manuscript treatise in the first chapters of Trattato di Musica. However, through the discussions, I think, with Martini and Balbi, with an important difference. As he writes, dopo prove si fatte, ella non credesse mai, signor Conte, che io pretendessi in forza del mio sistema di andare incontro alla quadratura del circolo. Pretendo bensì il contrario, ed è di dimostrare la impossibilità della quadratura del circolo in forza appunto del mio sistema. Ciò premesso, dico impossibile la quadratura del circolo rispetto alle idee a modo e scienze comunemente note di quantità. E qui rispetto alle scienze note di quantità finisce per sempre la ricerca della quadratura del circolo. Well, actually we know that it didn't quite end here, because they solved the problem later in the 19th century, but not with the tools that Tartini tried to solve it with. So, in conclusion, I can say that it is evident from the letters that Tartini wrote to Martini that ancient music theory had a profound impact on him and on his musical theoretical thought. Well, the question remains, why did he even adopt all these ancient canons? Why did he even read Zerlino's treatise, for example? Of course, there must have been many reasons, and many reasons are possible, but one of them may also be that besides a virtuoso violinist and a prominent composer, Tartini also wanted to be recognized as a scientist. Perhaps he found this inspiration in the very Zerlino's definition of the perfect musician, so that is the musician who engages in both musical practice and music theory, and it's perfect in both. And in this point of view, he has undoubtedly succeeded. Like Zerlino, he was a musico perfetto. Thank you very much.
Thank you, Nate. The discussion is open. Your questions. I think that this presentation was a very nice overview of correspondence and with Tartini and Martini, and I'm looking forward for more detail in your paper. But if someone wants to ask something, go, Pierpaolo. Unmute, thank you.
Thank you. Thank you for this very nice presentation that shed some light on a quite difficult topic in Tartini studies, namely how we track down the sources of Tartini. And it's pretty clear that Tartini quotes from Plato directly in the Scienza Platonica, where you can see the Timaeus, the 7th book of the Republic, and the letter to the friends of Dionys, and so on. But I never figured out where he actually got the sources, and I don't think that Tartini was able to read Greek. And when I asked Pierluigi Petrobelli, his idea, though he didn't know, but his idea was that there was it was in the culture of the academias in Padua, so a lot of these ideas circulated orally, or people would quote from their own translations. So it's still very hard to track down the precise Platonic sources. I don't know exactly how to go from there, but I think that the future of this of this research is pretty much trying to figure out what are these sources.
Yeah, thank you.
Roberta?
Yeah, many thanks for this very interesting presentation. I have a question concerning the slide about the three groups of letters. So there seems to be three quite isolated groups. Have you already tried to compare this with other correspondences of Tartini? Just such, for example, the Commercio di Lettere with Giordano Riccati as an example.
No, I'm sorry, I haven't. But if I remember right, the Commercio di Lettere, so the letters from Riccati, they only they start in the 1750s, if I'm not.
There is this edition by Luca del Fra, and then another and this started from December 1759 to November 1768.
1759, yeah.
For that reason, it would be really interesting for you, because 1768 is the very same year of the last group, but 69.
Yeah.
And then he notices a difference, that there is a discussion between Tartini and Riccati concerning the principle of harmony, just only in 59 and 60, but then no longer on these topics. But I have no idea about which other topics they were talking about. Just due to dependence, you know, as of from physics towards metaphysics.
Okay, since when now we are working on this edition of Let's do the newest one of Giorgio Malagò. I only took these letters because I was working on them. I didn't yet make any comparisons to other letters. But yeah, the letters from Riccati are of much later time. Yeah, but I have to say I don't know the content of those letters now.
Yeah, it's quite interesting only because this matter of physical metaphysics, because at least this early group with Riccati is concerning the coincidence theory and again Galileo. But then it would be interesting to know where is the turning point to metaphysics, at least in this other group of correspondence.
Well, this was just my impression. The groups I made, it was just my impression from these letters, so from the letters that
consistent with other research results, but we have, you know, this different research projects, and then we just try to get a picture of the whole.
Yeah.
Many
okay. Thanks. Yeah.
And maybe Roberta, we shouldn't look for a point, but the whole process, as you said now.
Only as tendencies and maybe in the individual issues, also some turning points in a certain discourse.
Yes. Any question? Other questions? Professor Durante?
Wait, my audio. Okay, can you hear me?
Yes.
And nice, thank you very much for your work. No, I was just thinking, it's not more than a question, it's a comment. There is another direction in which perhaps we could develop this line of thought. And that is, if there is a relation between Tartini, the reader, and the metaphysical thought during the Enlightenment. That's, I think, a possible theme. There are no hints in the letters, as far as we know, about this. But there was an ongoing discussion, even a discredit of metaphysics, of course, which is perhaps the most notable trait of Enlightenment thought. But this is in itself a point of interest. And the other thing is that actually we discover a Tartini. I may say, which shows, despite his illusions, shows a very critical mind, the intention even to overcome his own ideas. So in this sense, I find that his character, this character of musician, is absolutely unique.
Thank you.
Thank you very much. I would invite everybody else to post their other questions and comments in Zoom chat. And I suggest we pass to our next presentation, which is Professor Richard PARNCUTT from University of Graz. Richard PARNCUTT is Professor of Systematic Musicology, University of Graz, Austria, and Director of the Center for Systematic Musicology. He was President of the European Society for the Cognitive Sciences of Music from 2015 to 2018. He holds bachelor's degrees in music and science, an honors degree in physics, and an interdisciplinary PhD in psychology, music, and physics. His research addresses musical structure, music performance, origins of tonality and of music, and musicological interdisciplinarity. So today, he will present Tartini's harmonic theory, fundamental psychological problems. Please.
Okay, thanks for the kind introduction. I guess you can hear me now. So, you know, I'm not a historian. I'm going to talk from my psychological perspective. I might make some mistakes. It's a great privilege to be surrounded by historians who actually read documents, because I'm limited to secondary sources. So I'd like to talk about the big picture from a psychological perspective. I'm trying to understand how musical structure works. Now I'm going to see if okay. So first of all, I'd just like to say a few things about combination tones. I can remember once I tried to play a recorder in a recorder ensemble, like these pictures, these people you can see here, and there were combination tones happening quite often, and I noticed the person next to me seemed to make this buzzing sound in my ear, which was not part of the musical score, and those tones were quite irritating. And so if you've had this experience, you would realize that combination tones are unlikely to be a foundation for musical consonance if they actually sound dissonant themselves. You can listen to combination tones in the internet. Here's a demonstration that I found, which I found quite effective. I won't play it now, but you can easily find this one. You realize after listening to this that the combination tones are almost never audible to musical audiences, and only if the tones are very loud and you're playing the violin and the violin is right next to your ear, you're likely to hear them. Just clarifying the physical foundations of combination tones, you can look at either pure tones or complex tones. And so if you just have two pure tones, in this picture we see two pure tones, and you should imagine that the frequencies are changing gradually and continuously going up, not like in the picture. And if you do that, then the combination tones move gradually, and there's nothing about ratios of small numbers in such a representation. The connection between combination tones and ratios of small numbers, which is the foundation of part of Tartini's thought, only comes when you have complex tones. And so if, for example, we're playing a major third on the violin on two violin strings, the green lines could be the partial tones or harmonics of one of the tones, and the orange ones could be the other tone, and the interval is a pure major third 4:5 ratio. When that happens, then each pair of partials in this complex spectrum can produce different combination tones. And because the interval is exactly 4:5 ratio, these combination tones tend to add up at certain places, and then they become audible. So that's the process whereby Tartini heard these combination tones, discovered the phenomenon. And before continuing, I should also just say a few brief things about ratio theory. Let's imagine we're playing this major third interval. then we can imagine there are two different possible tunings of this interval, which is a long tradition in music theory, either the pure or the Pythagorean one, and the difference between them is something called the syntonic comma, which is approximately 22 cents. So the question is whether these two things actually exist, and I find it quite astonishing looking back over millennia of music theory history that people accepted that there were these two possibilities and that it was impossible to distinguish between them, but nevertheless continued with ratio theory, although it had this obvious problem built into it. Which one of these two is the right one? So Zarlino said the one on the left, the just, is the right one, and the Pythagoreans said the one on the right is the correct one, and actually there's no evidence for one or the other. And every interval in the chromatic scale has these two ratios. So if we look down this list, the number of semitones is in this column. I presume you can see my mouse going up down the column here. And each one of these intervals has two different ratios. And it's generally impossible as an acoustician or psychologist to say which of these two intervals is the correct one. So this is how Tartini was thinking in the context of 2 millennia of theory based on ratios, which from a modern scientific perspective is deeply problematic. I would like to compare this to what's happening today in psychology and for the last few decades. If you're studying psychology and you want to find out something new in psychology, to find out the truth, people expect you to do an experiment and they expect it to be quantitative. There's an emphasis on producing numbers and showing that one average number is bigger than another average number by statistics. The critics of this method are the qualitative psychologists who say that in psychology, the quantitative imperative is an egregious, potentially self-perpetuating form of methodological error. So what this statement is saying is at a very high level, this belief in numbers is not necessarily the way to find out the answer to scientific questions. We can apply this idea also to 2 millennia of music theory history. Let me continue with my rather naive overview of the history of music theory. We can see there are 4 different phenomena that the ancient Greeks wanted to explain, and actually in other non-European cultures. The beauty and wonder of mathematics, the magic way numbers work, the beauty and wonder of music as a completely independent thing, and then the cosmos, being stunned by the beautiful night sky with the stars in it and the enormous size of the cosmos. And then there's a human psyche, which is a very mysterious thing. And we could say that the ancient Greeks and many other ancient people, and still people today, are jumping to conclusions when they believe that those 4 things are related to each other. This way of thinking actually was very successful because Newton and Kepler and other famous people in the history of physics would never have had their brilliant ideas without starting from this logical fallacy. And even Einstein was talking a lot about the magic of numbers and the divine foundation of his theory of general relativity. We could also say from a modern scientific perspective that the whole music theory tradition did not actually work, because as I'm going to try and explain later, the foundations of music theory, which goes through Boetius and Zarlino and comes down to Tartini, is actually fundamentally incorrect. So we have a kind of quantitative positivist spiritual music theory, which is what we're studying. It's based on numbers, the belief that numbers are superior to words in order to explain things, which sometimes is true and sometimes not. Positivism in the sense that we can find out absolute truth by looking at these numbers, and also a spiritual level. In the case of Tartini, of course, he was a devoutly religious man, and he saw a connection between the creation of God and the beauty of the soul and the beauty of music. Here is an example of taking the idea of ratios and numbers a bit too far. I'll just read this translation out. Since there is no beauty and pleasure without proportion, and proportion is to be found primarily in numbers, all things must have numerical proportion. Consequently, number is the principal exemplar in the mind of the creator, and as such is the principal trace that in things leads to wisdom. So my claim is that this is the fundamental misconception which dominated music theory for a long time. Boethius, a great philosopher of the medieval period, great medieval music theorist, had these quite absurd ideas about number ratios and the large numbers which are involved, which are illustrated here. Tartini and Rameau were talking about the ratios of musical chords at about the same time in the 18th century. And so there are fundamental problems here. If you think that a major triad has the ratio 4:5:6, which would be the just ratio, then you would have to think the minor triad was 10:12:15, which is very unlikely because the numbers are far too big based on the assumption that the numbers should be small. And the whole story about the minor seventh, which if the ratio is 4:7 in this so-called just system, it would be 1/3 of a semitone flat compared to 12 tone equal temperament. It sounds quite out of tune, and I guess the historians will tell me if Tartini had any evidence that anyone would play such a flat minor seventh in that chord. So there are other things which Tartini would have been aware of, which contradict his idea. One is the idea that all large intervals are stretched. And so if you play a natural harmonic on the violin that's very high, it generally sounds flat because the octave intervals going up to a natural harmonic are 2:1. But in fact, our ear expects the pitch to be higher because of the stretching of the octaves. So here's an example of someone from the history of physics who actually talked about music, an example of successful application of this idea of number ratios and the connection between the cosmos and the ratios. This is how Kepler came up with his idea of the way to explain the motion of the planets. And another example is Newton. So Newton totally revolutionized physics by playing games with numbers and mathematics in a similar way that the musicians played games with numbers. He devoted some pages of his optics to describing an analogy between the color spectrum and the musical scale, which we know today has absolutely no foundation, but it inspired him to solve amazing physical problems. He claimed that Pythagoras had used the musical analogy to express knowledge of a heliocentric planetary system governed by universal gravitation. Well, this is very misleading. So perhaps mixed up in all of this story is a confusion what is meant by empiricism. There's an ancient philosophical idea of empiricism, which is based on subjective sensory experience and using your head to think clearly, logic, the tradition of logic, which is what philosophers mean when they say empiricism. But scientists use exactly the same word, and in that case, they're talking about experimental design, objective measurement, and mathematical modeling. Of course, both of these approaches have virtues and should be applied to different questions in different ways, but often they get mixed up with each other. So in this table, I'm trying to summarize some basic things that I think are important for understanding musical structure. We can see that in the 18th century, there were some absolutely basic ideas that helped us later to understand the structure of music. One idea was Rameau's idea of basse fondamentale, which was revived in the 20th century by a German psychoacoustician called Ernst Terhart in Munich, with his theory of virtual pitch, which is basically about recognizing the harmonic series inside of musical sounds, and is often considered the best theory today to explain the root of a musical chord. Now, it has a slight problem, and that is when you hear a virtual pitch, at the missing fundamental of a harmonic series. If you listen to it very carefully, it disappears. If you pay attention very carefully to this thing called a virtual pitch, it's no longer there. But it still seems to be a very promising theory. And on the other hand, Tartini's theory of the third sound, which is almost the same as what Hindemith was talking about in the early 20th century when he suggested combination tones, the foundation of musical roots. These things are inaudible in music, and we would normally assume that if something cannot be heard or perceived, it's not going to play a role in music. So I would say that unfortunately that idea turned out at the end of history right now to be not useful. And another idea which seems to come in the same category as Alan Fort's idea, many other people's idea, of pitch class sets in music theory. Now, it's very hard to recognize these complicated sets, and a lot of this mathematical theory is a very long way away from perception, but nevertheless, we would find that to be a useful theory in music theory. So having said all of those things, I would like now to answer a question which Tartini might ask if you were here. So what if Tartini were here today, attending this conference? He would say, okay, you people, you've been working on this for another couple of centuries. Surely you've come up with some good answers by now. I want to know what music's really about, where the structures come from, how do those intervals and chords work? And I think the following is what we might say today on the basis of our psychological and physical knowledge. First of all, what is a musical interval? Well, we know from millennia of music theory that people thought a musical interval is a ratio of numbers, but in a modern psychological or psychoacoustic approach, we would say that a musical interval is a cultural and psychological entity, and it's not mathematical or physical at all. This is a misleading idea, which was very, which we entertained for a long time. An interval is just like something else out of music, which you learn from experience and then pass on to the next generation in an oral tradition. The exact size of a musical interval depends on many different factors in performance. Of course, it depends on number ratios, because if you try to minimize the beating between two tones, you tend towards number ratios. But also there are many other factors, the structure of the scale, the tendency of one note to go to another, the stretch of intervals, which I talked about, the function in an ensemble. If I'm playing the solo violin, I tend to play sharp and the other people are playing flat relative to me. We're used to hearing that, and so it sounds right. Emotional expression, I might gradually push up towards a certain tone and then reach it with a certain delay in order to express something. So this is what intervals are really about, and combination tones, because they're rarely audible, are hardly likely to have any effect on this. So Tartini also wanted to explain musical scales, like many generations of music theorists. Today we would say that scale steps are approximately defined pitch categories in the sense of categorical perception in psychology. And so each of these pitches here can be shifted up or down by in a certain range, and we still say that is the note, right? You can play F up and down a bit relative to F on the piano, and we still hear it as F. So theories based on exact ratios are misleading. The idea of the diatonic scale being a chain of fifths is of course true, but because the equally tempered perfect fifth is so close to the so-called pure perfect fifth, and because this interval of 2 cents is so small compared to what we can perceive, we should say in a modern psychological approach that the chromatic circle of fifths is closed and complete, and there's no problem to be solved there. Enharmonic equivalents are a product of a notation system which is based on the diatonic scale. So a lot of music theory which talks about the difference between enharmonic equivalents is actually misleading, because it's founded on an arbitrary definition of enharmonics in a notation system. A third question that Tartini was very interested about was how to explain chords. We've mentioned before that many theorists thought this dominant seventh chord had the ratio 4, 5, 6 to 7. So what is actually happening in a psychological sense? In a psychological sense, we could say that there's a chromatic scale which has evolved over many centuries of music history, and chords are simply selections of tones from that scale, and some are more or less consonant than others according to principles here. I wrote down smoothness, lack of roughness, harmonicity, closeness to the harmonic series, and familiarity. We know today how the inner ear performs a kind of spectral analysis to separate the frequencies. The voiced speech sounds are producing a harmonic series in the inner ear. So every time you listen to someone talking, your inner ear is analyzing the frequencies and sending information about the harmonic series to the brain. So the brain is very familiar with harmonic patterns and somehow uses this ability to perceive the roots of chords. And in this approach, the problem with the minor triad disappears. It's not a problem anymore. To understand major-minor tonality, we would say that tonality is generally a prolongation of the tonic triad. And the reason why there are two keys, major and minor, in the common practice tradition is because only two triads, the major and minor, have a perfect fifth interval and have no second interval, and that's why they're relatively consonant. And so these sound like naive statements, but these are actually answering questions which were central for music theorists for many centuries. So finally, I would just like to ask the question why Tartini was so interested in explaining tonality, but today we don't seem to be so concerned about it anymore. So a good thing is the idea of relativism in music history and music theory, which says that if you want to understand the ideas of someone from the past, you have to get into their frame of mind and you have to understand the context in which they were thinking in the 18th century or whenever that was. And also, we have to be aware of the inherent difficulties of explaining something as complicated as a musical system, so we should not jump to conclusions. And this is why music historians today are very cautious about saying anything about how music actually works. Instead, we talk about how the theorists of the past described this problem. But there could also be some other problems. I believe that many musicologists still have not rejected Pythagorean numerology. The idea that a musical interval is in fact a ratio is not completely crazy for many people. It is for me. And the idea of just tuning is also not rejected. So many people believe that if you're singing Renaissance music, for example, in a choral ensemble, that just tuning is the ideal to which you should approach. And in fact, there's no evidence whatsoever for that in scientific measurements. The evidence is more like we're familiar with the piano and therefore we should sing like the piano. Okay, and there's also some ideological things going on in modernism still. So that's the end of my talk. Thank you for your attention.
Thank you very much. This was a very different perspective, for sure. I think there are a lot of issues to be discussed. And in my opinion, we don't do justice if we try to put Tartini in this 20th century frame. Mm-hmm. Like you said now in conclusion, we have to understand the thinking of Tartini and his time, but also I think that they listened music in different way. Their ear was accustomed differently. And our ear adapted to the different tunings developed later. But let's open the discussion for all questions.
I have a couple of questions.
Go.
So first of all, many thanks also for this perspective. The first point is maybe a piece of advice. Are you maybe aware of the current work of David Cohen in Frankfurt about these so-called Pythagorean revivals in music theory?
Can you spell the surname, please?
David Cohen.
How do you spell Cohen?
Cohen.
Just like
Cohen.
Cohen. Yeah, yeah.
Okay.
It's
Okay,
the Max Planck Institute in Frankfurt.
Okay, no, I haven't seen that. I'll have to look at that. Thank you.
There's a current book project, and a couple of years ago it was maybe concerned with this so-called Pythagorean revivals. So it's a part of your topic in a kind of way.
Yeah.
And the second point is, yeah, this is for me, of course, another point of view. And in one of your last slides, you just departed from the 18th century. And this is in a discourse about Tartini, for me, of course, too late, because we missed the background in the 60th and 70th century. So even in the matter of a scientific method, you can take, of course, the scientific method in a narrow sense, and this hypothetical deductive method, but this is already not the whole questions. We need, just due to the structures in university at that time, to distinguish, for example, between logicians and scientists, or just very quickly about the concept of logica docens or logica utens. This is pure logic or applied logic, just an example, or between experience of different kinds and experiment. So this is a whole word, but this is also the background of Tartini in a sort of way.
Thank you. I'm not very well informed about the details of Tartini, and I was more concerned to describe the general context in which his ideas were developing. And I'm sorry if I go back to the start of my talk. At some point here, I talked about these four things: mathematics, music, cosmos, and the psyche. I'm actually interested to talk on a very general level about the connection between these four things. And you're talking about a specific version of this discourse which happened in a certain historic period, which I'm not very well informed about.
Yeah, because you also talk about the role of mathematics, but there are different possibilities, you know, just about as a mathematics as a model in the context of universal science, and just a model for what, etc. Yeah, also this is just some hints to the historical discourse. And now there will be a lot of literature on it, just because we have also the Galilei anniversary this year. Yeah.
Thank you.
We have time maybe for one more question.
I'd like to ask a question, and I found that being a total ignorant about psychology of music, I found the paper totally fascinating, and I would like to ask you. I mean, since you demonstrated essentially that consonance is actually a cultural product of some sort, how crucial do you think it is to restore the original conditions of the way in which the music by Tartini or anybody else in the century was performed in order to reach its inner sense?
I'm not sure if I understand your question. So you're saying that if we understood the psychological foundations of consonance, would we be able to perform the music more effectively? Is that your question?
Well, the question is, I mean, how crucial was the difference of intonation that Tartini imagined for his string orchestra in order to, let's say, catch elements of the music, not all of it, but elements of the music that possibly the people of the time would have considered essential?
I think if Tartini had an idea of intonation, he was listening with his ears to what sounded good to him, and it was very difficult for him to know if he was coming close to pure intonation, which he theoretically wanted or not. Instead, he could hear that it sounded good for some reason, right? And so without physical measurements, we have no idea of exactly what that was like. And at the same time, even if it was performed today the same way as it was performed then, our psychology is different today, so our experience today would again be different. So the whole question is so difficult, I don't know where to start. So perhaps it's possible that he was aware, I'm not sure how aware he was of equal temperament, exactly how that worked, if he talked about equal temperament in his theory, but if he was aware that the pure major third is a bit smaller than equal temperament, he may have deliberately tried to play slightly smaller major thirds in order to give a certain effect, but I'm not sure if that's even true.
I mean, in matters of intonation, he was clearly, you know, on the line of Valotti, essentially, and he was totally aware of the fact that keyboard instruments had problems that he considered acceptable, and yet he preferred not to have to do with that kind of intonation if he didn't have to, if I may put it this way. Which poses a problem, of course, for bass realization in his music, if you want. And so, and then I have no idea how they would listen to music at the time, but it's puzzling to me that such, let's say, negligible in a sense differences could become in reality something very essential to catch, let me say this, the spirit of that music.
I guess my radical answer to this question is that the spirit of this music has nothing to do with the theory of intonation at all. The spirit of the music is something completely different, which musicians found out intuitively by performing it in order to make the oral experience that they want. And the intonation is a digression. This question about ratios is actually not relevant for performance at all.
Well, this is definitely a radical answer. I thank you for the clarity.
Thanks.
Thank you all. We should now pass to our next presenter, which is Bella BROVER-LUBOWSKY. I would ask kindly Professor PARNCUTT to stop sharing his screen. Thank you. And Bella BROVER-LUBOWSKY is a professor at the Jerusalem Academy of Music and Dance with expertise in musicology and history of music theory. She is the author of Tonal Space in the Music of Antonio Vivaldi, the early reign of Oleg music for the play by Catherine the Great, and of numerous articles on 18th century Italian music and writings on music, the Epistemology of Tonality and the History of Modal Dualism. She is a recipient of the research grants and awards from the Einstein Stiftung Berlin, Research Institute of Music Theater Studies, the Israel Science Foundation, the Italian Academy for Advanced Studies in America, the Vittore Branca Center for the Study of Italian Culture. Today, she has presentation No Other Art Than the Imitation of Nature, Tartini, Algarotti, and the Hermeneutics of Modal Dualism.
Can you see the PowerPoint? Thank you very much, Lucia. Excuse me. So it has been said much on Algarotti in context of Tartini's music and writing, and I want to offer to examine the conceptual link between them. The link that possibly helped Algarotti to shape his theories and to disperse them in various fields in mid-18th century European culture. Testimony to their direct relationship is not only on their correspondence, Algarotti, the most decided proponent of the emerging neoclassical movement, refers to Tartini in his essays and letters to a number of addressees, mentioning the incomparabile Tartini as an exemplar of naturalness and simplicity of style. I aim to explore the modes of Algarotti's reception of Tartini's music, which mirrors the climate of opinion in European culture of this period. Algarotti was one of the most glittering figures of the Settecento. Poet and savant, he was also an accomplished courtier, friend, and confidant of kings, artists, literati. His writings include essays on painting and architecture, language and drama, natural philosophy, history, military science, economics and politics, anatomy, astronomy, and travel diaries. His occupation with musical matters is commonly encompassed by his saggio, Sopra l'opera in musica, in which he preached holistic ideas based on Greek tragedy. His vision of opera as one regular and harmonious whole, whose beauty should result from all the parts being properly adjusted together. And it sheds further light upon his ideological syncretism. Fascinated with the relationships between various fields of human activity, he furthers notions of the systematic commonality between arts and sciences, attempting to produce a new synthesis between sensuality and rationality. In 1728, the 16-year-old Algarotti, a student in the famous Istituto delle Scienze delle Arti in Bologna, was encouraged to replicate the Newton's experimentum crucis on the refraction of light and the immutability of spectral colors before the members of the Instituto. And this is the illustration from Algarotti opera, second volume. A similar series of experiments conducted there earlier by Eustachio Zanotti and in the University of Padua by Giovanni Rizzetti had failed. Spectral colors kept changing when passed through the second prism. Algarotti's was the most scrupulous and carefully documented replication of the experimentum crucis ever conducted on the continent. Actually, in France, there was Edmond Mariotte who failed as well to reproduce the Newtonian experiment. Algarotti's prismatic performance was staged again and again in front of academic, clerical, and lay audiences in defense of Newton's theory, and provided the backdrop of Algarotti's bestseller Il Newtonianismo per le dame, ovvero dialoghi sopra la luce e il colore. Completed in 1737, in 1738, it was placed on the Index of Forbidden Books, but it was published in the same year in English translation, and I will be quoting from this edition. The book is composed in the form of a dialogue between a cavaliere and an anonymous marchioness. And the Marquise du Châtelet was a prototype of this marchioness. The cavaliere, this is an illustration from the frontispiece of Il Newtonianismo. The cavaliere assures her that optical experiments can offer, quote, the most beautiful spectacle you can ever imagine. And their literary representation can be, quote again, more magnificent and pleasurable than many of the scenes seen at the opera. The survey begins with a historical overview of various systems of the universe and their respective doctrines of the nature of light. Systems by Descartes, Malebranche, and the anti-Newtonian Giovanni Rizzetti. At the end of the Marchioness adopts Newton's theory of light as a part of the entire Systema Mundi. At various points, Algarotti equates the association of abstract thinking and mathematical practice with masculinity, in contrast to a supposedly female inclination for feelings, imagination, and social skills. Quote, that sex which had rather perceive than understand. Thus, Algarotti seems to reinforce the gendered view of intellectual faculties. In fact, his masculine-feminine imagery is a metaphor of the rational, sensual implications of natural sciences. And the true goal of Il Newtonianismo becomes to transfer the sciences, I quote, from the solitary closets and libraries of the learned and to introduce them into the circles and toilette of ladies, which means to popularize and domesticate the optical ideas within the cultural consciousness of his time. By using shared rhetoric, terminology, and modes of discussion, he applies new scientific methods and discoveries both to various natural phenomena and to artistic endeavor. In this way, Algarotti believes that he, quote, brought into Italy a new mode of cultivating the mind. Right at the starting point, the Martinez declares, I am pleased that poetry and natural philosophy have one common date. This, in the language of philosophy, is called making systems. Algarotti focuses on demonstrating the cultural and artistic implications of optical discoveries. By his writing, by this means will your dexterous philosopher compose not only the finery of silks and the variegated beauties of a garden, but all the elegance of Paolo Veronese or the delicacy of Titian. When explaining Malebranche theories on optics, Algarotti pays tribute to the synesthetic aspect that light and pitch have in common. He extensively elaborates on the consanguinity between the, I quote, system of light and sound, these two new brothers in natural philosophy, discussing the physiological basis for the phenomenon of synesthesia. The optic nerves resemble two lutes composed of various strings, which have an exact correspondence with each other, so that the two images of the object falling upon strings wound up of an equal height or a unison, etc., etc. Algarotti also addresses the ocular harpsichord, an instrument invented by Louis Bertrand Castel and cultivated in Paris in these very years. Castel modified the harpsichord mechanism such that the pressing of the keys would bring out the colors with their combinations and their chords. In one word, with all their harmony, Algarotti. Castel wrote of the génération harmonique des couleurs and of a combination of this color scale with chordal sonorities. Algarotti addresses Castel harpsichord, emphasizing the culmination of auditory and visual experience and the extended expressive effect of such a combination of harmony of sounds with that of colors. The harpsichord of colors and the music of the eyes gives a still greater confirmation to this new alliance. It is indeed a new invention. Upon moving the keys of this instrument, instead hearing sound, you will see colors and mezzotintos appear, which will produce the same harmony as sounds do. The sonatas of Rameau and Corelli will give the same pleasure to the eyes when seen upon this philosophical harpsichord, as they do to the ear when they are played upon the common sort. The concords of a piece of purple and scarlet will raise the passions of love, pity, courage, or anger in our souls. The transient pleasures of the ear will be fixed in the eye. You may continually enjoy the fine airs of Farinelli wove in a piece of tapestry. Algarotti's description is the earliest discussion of synesthesia in its physical, cognitive, and expressive aspects before Goethe's Geschichte der Farbenlehre. The Cavalier over-occupation with the idea of, quote, flattering our sight by the concords of harmony becomes almost annoying, so that eventually the Martinez exclaims, who knows, but we may sometime form a dîner by the assistance of a harpsichord and find a harmony in a fricassee. Algarotti always refers to Tartini's music via these synesthetic parallels. Like, for example, with regard to Piccolo sonate, supposedly sent via him to Frederick the Great. Algarotti writes, your sonatas, due to their grace and beauty, cause one to forget about Corelli and instead recollect the style of Raphael and Petrarca. In Saggio, Sopra l'Opera in Musica, he again refers to sonatas of the incomparable Tartini, where there is a joint variety with the most perfect unity. Before starting to write, he usually reads some compositions by Petrarca, with which he greatly sympathizes with the subtlety of sentiment. And these two have before a given theme to paint with the various modifications that accompanied it and never lose sight of the motive or the subject. Why does he mention Petrarca? Why does he mention Petrarca twice even, at least? Probably he is alluding to the poetic motions in Piccolo sonate. But what fascinates Algarotti most of all is this similarity and commonality of the development of expressive ideas in music, in Tartini sonatas, and in visual arts, and in poetry. This echoes Algarotti's synesthetic merging of disciplines when he exclaims, this sound and this light seem so faithfully copied one from another, as if they were the portrayals of nature. Similar to Algarotti, Tartini's Systema Mundi also lies within the context of a launch for unity of knowledge. In his letters to Algarotti, Tartini expresses his Naturphilosophie, a concept of universal reality as immeasurable, infinite, and essentially incomprehensible, taking his task as revealing to mankind its unifying principles. He believes that nature is the sound of every truth in any field. Its essential task is to regulate different orders of phenomena through principles that can be reduced to specific mathematical formula and geometrical abstraction. The explanation of the minor third and minor triad as a direct gift of nature, along with the acoustical definitions, was one of the crucial issues raised in contemporaneous discussion. The conceptual and rhetorical similarities between the ideological battles deployed in optical and acoustical theories of the arrangement of the tonal space are truly striking. Pairing of the major and minor triads and modes based on them is expressed by various usage of chiaroscuro metaphor. The theories of chiaroscuro and shadows in painting and their practical implementation, as art historian Michael Baxendale proves, is as well a discovery of this precise period. And it is contemporary to the formation of the concept of modal dualism, and it is corollary to the Newtonian optics. In Newtonian optica, the refraction and the refraction of the white color into the spectrum is just one matter that is proved empirically. But Newton writes a lot on the transparency and opacity of objects, and on the alternation of white and black circles as an optical effect. So when Martini remarks, we need only consult the thirds of this harpsichord, the Castell harpsichord, and we shall be sure never to make any discord in the shading. This as well mirrors the Algarotti's and Tartini's shared perception of the unity of all this field. And just to illustrate the measure of Algarotti's intrusion into all this business of transmitting the optical discoveries into various fields in the art, I will show the quotation from Algarotti's letter to Stacchio Zanotti in Bologna, when he's writing that one fantasy has visited me, it will be better to use white ground for oil paintings and to leave the reddish brown that is in vogue nowadays as a corollary to Newtonian optics. And Algarotti is writing this when he is in Venice in 1754 to 1756, when he is purchasing the pieces of art for the collection of Frederick the Great. So he is in a dialogue, oral dialogue with Giovanni Battista Tiepolo, and there are two paintings, oil on canvas by Tiepolo. One, the L'apoteosi della Barbaro Famiglia, is on the ground, on the brown ground for canvas, and the second one, later, L'Allegoria con Venere e il Tempo, on the white ground. So we can see how Algarotti actually impact the changing modes of creativity in various fields of European art. Similarly to Algarotti and the entire intellectual environment of their generation, Tartini believed that the universal laws learned through the new optical discoveries could be projected onto music via acoustics. Tartini frequently deploys color-oriented and optical metaphors of modal dualism, like, for example, when he's writing about Valotti playing on organ, and he says that he observes what pleasure results from playing the organ by reasons of comparison of the major and minor perfection of the chords with respect to the various modulations required. If the temperament were equal, or a little more, little less than equal, there certainly would not be that chiaroscuro, which in practice produces an excellent effect. Tartini's colleagues in Il Santo justified the system built on the dichotomy between the major and minor thirds, triads, and modes. However, they offered several options for the model of for their most intimate pairing, most intimate and natural pairing. For example, the hexachordal C Ionian paired with D Dorian, like Francesco Antonio Caligari in the Il Santo Basilica, or the relative C major paired with A minor, like Francesco Antonio Valotti or Conte Riccati and Dramont, or even the C major paired with E Phrygian, like Alessandro Barca, from the same circle from Università di Padova. Tartini's concept of modal dualism depends on the pairing of the parallel major and minor triads. Hugo Riemann claimed that Zarlino to be the founder of this concept, asserting, however, that Zarlino's quote, splendid idea remained whether unnoticed or misunderstood for a full 200 years until it was recovered from oblivion and rediscovered by Tartini. Tartini attempts to maintain the systematic unity of his dualistic conception by deriving both major and minor triads from a hierarchy of relationships between hierarchy on relationships based on harmonic versus arithmetic proportions in dividing the string. He considers the minor triad as extrapolated from the unity of the tuone differenze in the major triad. By arranging the intervals of the harmonic series in the order of their appearance and deriving the combination tones of the first order, he demonstrated the existence of the C minor triad paired with the C major triad. So, as Tartini shows, various subdivisions of the string beget several complementary series, the first two of which create the symmetrically placed major ascending and parallel minor descending triad. The first harmonic series, says dupla armonica, creates and produces the major triad. The arithmetic series, consisting of the residual of the previous series, naturally provides the desired minor triad in descending order and the subdominant F. Tartini thus considers the parallel minor triad as an intrinsically inseparable consequence of major triad, and he's writing this and demonstrating in various treatises. How were these ideas mirrored in Tartini's music? In his major key sonatas and concertos, the insertions in the parallel minor, third, and triad are virtually compulsory, and I will show just some of the examples. For example, this violin concerto in G major, Dunius 73. Here in the first movement, we listened like an echo of the tonic minor insertion, and it happens again and again and again here in the first movement, and in the finale of the same concerto here in G minor and in D minor, like an alternation and fluctuation between the major third and the minor third.
Professor Brower, I'll just remind time.
Yes.
Thank you.
And so there are a lot of examples I could show, including the example that discussed yesterday by Tommaso of the Sonata Piccola in G major, and here is the parallel D minor insertion in the first part. So why does Algarotti apply his synesthetic metaphors to Tartini's music and posits him as an example of perfection? Algarotti frequently refers to other composers, Handel, Rameau, Corelli, Hasse, Marcello, Pergolesi, etc., etc. Apart from their being in close contact, Algarotti appreciated Tartini's evolution towards naturalness and simplicity. The progressive and programmatic lightening of the melodic harmonic syntactic structures that occurred in Tartini's music appealed much to Algarotti's neoclassical pretension. And in a letter, the last one, to Abbe Franchini, he says that actually, after Cornell and Racine and sonatas of Corelli, who may think that there could be anything new created, but nonetheless, Marcello and Tartini have shown us that in both fields, there are something more to add. So he appreciated and was fascinated, Algarotti, with Tartini's music, poetic unity of imagery, and the commonality between the theories and the practical implications. And this case of Tartini Algarotti shows that in mid-Settecento Italy, the natural sciences provided the epistemological model and language through which the musicians conceived their ideas. Thank you very much. Sorry for running.
Oh, thank you. Thank you. Just to leave some time for questions. Awesome. The discussion is open.
May I ask? This kind of harpsichord with the colors is only an idea, or it was realized somewhere, somehow?
No, this is the true harpsichord. He invented it in 1736, and even we know that Telemann wrote 3 pieces of music for this harpsichord. The music did not survive, but there are a lot of reactions, included Eulero, who as well is fascinated with this harpsichord. And when he is publishing in Berlin a letter, the Princess Alemann, he is writing about this commonality and says that the spectrum of sounds is parallel to C major scale, and he elaborates on this idea very nicely. Yeah.
Thank you.
I think that is it was very interesting to see thinking which connects different fields, and that discussion of the time. Do you think that did you find evidence in Tartini's letters that he thought about that in more detail, or just in general?
Of what?
Of connection of poetry, painting, and music.
Well, firstly, I should confess that I just heard about the publication online in free domain of all the Tartini's letters, so I did not read all of them, but he uses the metaphors, and when we are seeing all these spectral or color metaphors and chiaroscuro allegories, in light of Algarotti and Euler and literati writing in this precise time, we understand that it is not just a metaphor, but a mode of thinking. So I hope to find more. But what I did find is the similarity between what he is writing about parallel major and minor thirds, for example, and what he is doing in music. And it is very interesting, I think. And there are patterns of optical parallels with what he is doing in syntactical terms with motivic modules in his concertos.
More questions? Thank you very much, Professor Brower. I'm sure if there is a comment by Professor Durante in chat that there is not a reference to colors in Tartini's letters. But if there are any other comments and questions, please post them in a chat group. And I will now ask our last presenter of this session, ROBERTA VIDIC. Is that VIDIC? Okay. From University of Music and Theater Hamburg, Germany. ROBERTA VIDIC is a lecturer for music theory and a PhD candidate at the Hochschule für Musik und Theater Hamburg. Her dissertation topic is Palestrina and the origin of harmonic theories in early 18th century Italy. She has a degrees in harp and music theory from Udine, Munich and Hamburg, and studies in historical pedal harps and improvisation at the Schola Cantorum Basiliensis. Her research interests include the history of music theory from 16th to 18th century, musical form in fantasy and musical terminology. She is participating in international conferences and has publication on those subjects. She is a double winner of the scientific competition of the German Society for Music Theory, and her doctoral research is supported by Fondazione di Venezia and Fondazione Cini in Venice and the German Historical Institute, Rome. Today, her presentation is Tartini's musical inference between epistemology and history of harmony. Roberta, it's you.
So many thanks. I have only to premise that my own knowledge of philosophy of science comes actually from another master I'm pursuing instead at the State University in Hamburg. So I now come to my presentation. Can you see it? Okay. Assertion and deductive reasoning is very common in everyday thinking, as well as in legal argumentation and scientific hypothesis construction. This so-called defeasible reasoning has nowadays become more and more important in computer science and artificial intelligence. Nevertheless, its origin can be traced back to ancient philosophy, such as from Aristotle's posterior analytics. My paper will analyze the use of this kind of reasoning in writing of the Venetian theorist Francesco Antonio Calegari and of his student Giuseppe Tartini. Tartini explicitly introduces a term for musical inference, fundamento musicale, as a third kind of reasoning in his epistemological and historical discussion of the principles of harmony. Inferences are steps in reasoning moving from premises to logical consequences. The current convention in interdisciplinary informal logic there's any problem. No, okay. Inferences are steps in reasoning, moving from premises to logical consequences. The current convention in interdisciplinary informal logic is to postulate, besides deduction and induction, a variously named third category of inference. Charles Sandor Peirce added adduction as an example. This third category of inference generally happens in practice, where acetate additionally comes into play. Musical inference is therefore likely to appear at those moments in the history of music theory when theory is closely related to musical practice. Such inferences become especially relevant when theory and practice collide in musical controversies. A telling example for such a controversy is the role of the rule of the octave in the origin and foundation of modern harmony. In this sense, my two-part discussion will consider both historical and current controversies over this subject. In historical context, Caligari's main treatise literally represents a large demonstration of the major and minor mode, and this is part of his extensive manuscripts on tonality. Later on, Tartini explicitly uses the term musical inference for the third chapter of his dissertation on the principles of harmony in the diatonic scale, after 2 chapters on the inductive and deductive inference. In current scholarship, we observe controversies over the priority of Rameau as the founder of harmony, or over the rule of the octave as a valid criterion for a modern notion of harmonic functionality. Today, I will focus on the latter issue. The discussion of these materials will show that the third category of inference is not only relevant for the history, but also for the epistemology of harmony. In the first part of my paper, I will now consider the introduction of the rule of the octave from the historical perspective of Caligari and Tartini. Interestingly enough, the search in their writing for the real explanation of harmony is perceived as a continuing process that has begun about 2 centuries before their time.
I'm sorry, Roberta, to interrupt.
Yeah.
Could you please share your presentation in full?
Yeah, I did it, and that's what's the reason why I ask if there are any problems. I try again. It's better?
Yes, yes.
Thank you. If the historiographical problem of harmony regards the origin of tonality, the epistemological problem deals with the foundation of harmony as a discipline. In other words, it comes either to questions of priority or to questions of validity of a certain reasoning. In the first case, an inventor or discoverer of harmony as an art or as a science comes into play. In the second case, it is important to discern who tells the truth and furnishes a real explanations of harmony. Typical for all abductive argumentation schemes is to focus on the result and to search for an explanation from given premises. Therefore, the reasoning is not conclusive, leading only to a provisional conclusion. Especially where we face 2 competing stories, we speak of a subsequent process of inference to the best explanation. This defeasible reasoning can be a way to move on from apparently indissolubly problems in the description of the historical process. In this sense, Caligari's and Tartini's introduction of the rule of the octave in their respective system of tonality can be interpreted as 2 competing stories in terms of defeasible reasoning. They both come, in fact, from different premises to comparable conclusions and from tentative conclusions to provisional best explanations. The rule of the octave is a central argument. In the controversy over the minor mode, the so-called Magis Amica Veritas controversy between Caligari and his pupil Francesco Antonio Vallotti, and in the controversy over the article Fondamental or so to say, the calculations upon calculations controversy between Tartini and the French encyclopedist Jean-Baptiste Le Rond d'Alembert. As a whole, Calegari and Tartini introduced two different concepts of theoretical and practical writing and two different concepts of musical inference. In the following table, I simplified their respective argumentation scheme, taking only their steps immediately before and after the introduction of the rule of the octave. For Calegari, accompaniment practice cannot be fully explained through counterpoint or thorough-based teaching, especially in relation to the major and minor mode. For Tartini, on the other side, Rameau is seen as the inventor of harmony as a science, but Rameau, corps sonore, gives only a partial explanation of its natural principle. As you can see, both Calegari and Tartini introduced the rule of the octave and the cadence in a reverse order, in their respective inference to an incomplete and finally best explanation of the issue. Calegari's premise in his successive building of the major and also minor key is generally the accompaniment practice of his original works of Palestrina. These are, in this sense, two immediate premises to his introduction of the rule of the octave. First, the 17th century organist discovering the real modes with his hands at the keyboard. And secondly, Calegari himself analyzing the so-called Palestrinian practice. The following reasoning comes from Calegari's treatise of 1732. It is generally not conclusive because it just offers the best explanation for current practice. It is also consistent with other parts of Calegari's system, such as the explanation of the harmonic interval against the Lino. Nevertheless, it is important to notice that Calegari follows the same argumentation scheme for the octave as elsewhere for the interval. The result of this reasoning is this concept of co-participation of a main and its subordinate keys in the major mode, the basis for our modern concepts or relative keys and modulation. So you can see the three steps. First, natural condition with 7 various readings of the octave. Second, the so-called natural immutable condition with various bass motion. And third, the so-called perfect condition with additional transposition of the octave rule on F major, G major, D minor, A minor, and E minor. Tartini's premises in his successive building of the major key are both Rameau, corps sonore, and his host terzo suono as the natural principle of harmony. The immediate premises of his introduction of the rule of the octave are in particular the difference between the only 3 consonances of the Greeks, the 4th, the 5th, and the octave, and the modern addition of the major and minor thirds. An additional aspect in the discussion of the 3 cadences and of the major and minor triad in Rameau and his own systems. These are all the premises. In his treatise of 1767, the following reasoning is generally not conclusive because it offers again just the best explanation for current practice. But compared with Calegari, some moves on of the reasoning between the steps are clearly recognizable. It is important to remark that Tartini claims to have achieved, other than Rameau, a fully unified integrated system of the melodic and harmonic interval. For this purpose is substantiate each single rule or law on his own terzo suono. So you can see here first the scale and 3 main triads in current practice as a premise, then the scale with 3 cadences in a so-called regulate order, and again a perfect system, the scale with accompaniment and chord generation. So when I come to the second part of my paper, I will come to a recent debate about the role of the rule of the octave in the history of harmony. This debate mainly involved Thomas Christensen and Ludwig Holtmeier and reached its peak in the years from about 2007 to 2010. Therefore, it represents a nearly chapter in the ongoing issue of this century, the history of music theory, with a special focus on the local traditions of harmony. In this context, the historiographical problem of a various defined third category of theoretical reasoning develops after Karl Dahlhaus. We introduce the concept of paradigm shifts into the history of music theory. Following the historian of science Thomas Kuhn, Dahlhaus differentiated three paradigms called speculative, regulative, and analytic. Applied to the history of harmony from 6050 to 7050, as Christensen does, they correspond first to the speculative harmonics since Greek antiquity, and second to the practical harmony for composition. The third emerging paradigm can broadly be called music analysis. Instead, the epistemological problem of an implicit and explicit musical inference can now be turned into a problem of a variously named third category of inference in the social and natural sciences. In particular, Joveson and Jofson have grouped these three traditional inferences in a new taxonomy, leaving room for a new third category that is to be called a mixed inference. Against this background, I will now shortly reproduce a part of Christensen and Holtmeier's debate in terms of the feasible reasoning and associate it with three paradigms. To put it simple, I will comment on a series of certain historical facts and then compare them, the respective points of disagreement. It's all in the game that the competitors mainly focus on Jacques-Philippe Rameau. So first, the rule of the octave was introduced around 1700. 1700 was a time in which most musicians already dealt with a major and minor mode in their practice. The first point of disagreement regards the merely practical or also theoretical value of the rule. Christensen had previously observed that the rule originated as a rule of thumb for harmonizing an unfigured diatonic bassline. So, second paradigm, regulative. Holtmeier contradicts this argument in 2007 and calls the rule a crucial step towards a theorization of thorough bass, as well as an instrument of harmonic analysis. So, third paradigm, analytic. It remains out of question for Christensen that the mere introduction of the rule does not necessarily lead to a real inversional equivalence between the different forms of the chord, a central issue in his own argumentation. But something like this rule of thumb, as he writes in 2010, led Rameau to formulate his famous principle of inversional identity in 1722. Second argument, or fact. Rameau published his treatise in 1722. At that time, the rule of the octave was already established in France as a pedagogical model. According to Christensen, the rule served for students as an implicit paradigm of a mode and provided in this way a normative harmonization, so second paradigm, of chords for each scale degree of a given mode. Holtmeier's central thesis is that such a practice-oriented theory also essentially lays the ground for a more speculative theory, so for the first paradigm, speculative. Christoph Guillotin-Notman comments on Holtmeier's argumentation. Summing up, he says, although this central thesis is an important achievement of Holtmeier, the embedding of musical practice in the subordinate scientific and intellectual historical context remains largely underexplored. This is actually Christensen who provides a historical context with the controversy over the priority of harmony and melody. The rule of the octave offers, therefore, harmonization of the most basic and primitive melody at all, the scale. This helps further to explain why Rameau regularly returns to this question. A second explanation will be now furnished at the next stage of our reasoning, the last stage. Rameau's analysis of the rule in the traité is a turning point in the history of harmony. A major point of disagreement is the question if the addition of the basse fondamentale to the rule is a sufficient or even necessary condition for speaking of harmonic functionality. If not, it becomes easier to justify some inconsistencies in Rameau or to include further traditions besides Rameau in a broader discourse about harmony. Christensen substantiates that Rameau was clearly unsatisfied with his analysis of the rule of the octave and implicitly of his own definition of mode. So you can observe here the use of interpolated bass as an example. In Otmario's opinion, the rule of the octave is, already before Rameau or even independently from the basse fondamentale, a theory of harmonic functionality, a real harmony there in the modern sense, as it already codifies the terms major-minor tonality and cadential harmony. As a whole, I'll come to the end, only Christensen furnishes an explanation for the fact where Rameau returned to the analysis of the rule with the basse fondamentale in all his major publications. One necessary adjustment regarded in this sense Rameau's introduction of the subdominant, but the subdominant, as Christensen remarks, did not jump out at Rameau simply through its empirical reiteration in musical practice. It was clearly something that had a more speculative origin through his notion of the geometric progression. At this point, I have to stop and come to two provisional conclusions and a final word. Christensen's merit is to have suggested that the relation between theory and practice is, in his wording, a dialectic one in which theory suggests certain formulation that might be tested in musical practice, and conversely, musical practice suggests certain empirical data that demand explanation. Holtmeyer, on the other hand, opened up new perspectives for the so-called decentering of the history of harmony. It shows us what he claims to be one of the greatest failures of music theoretical historiography, the unilateral fixation on Rameau that has blocked the view on the Italian traditions. Both perspectives are necessary for historicizing the documents of Calegari and Tartini we examined at the beginning of this paper. They also reflect two tendencies in the ongoing debate on the history of music theory. The first one, the poetics of doubt cultivated by Dalhaus, has been reformulated by Christensen and later discussed by Guillotin and Ottman in a European perspective of recent tonal theories. For Guillotin, the poetic of doubt implies that theoretical positions, whether historical or contemporary, are never neutral, but are based on more or less obvious conditions of proof. Finally, a so-called taking a look, or the second attitude in Ian Hacking's New Historicism, has been chosen by Nathan John Martin for delineating an enhanced potential renegotiability of many of our basic music theoretical categories. Its three possibilities might include, besides Rameau basse fondamentale, also Heinrich's four-based theory and the rule of the octave schemes in the Partimento tradition. My personal choice will certainly include Calegari's and Tartini's tentative reasoning and searching on the rule. Thank you.
Thank you very much, Roberta, for this interesting presentation. It shows really how certain, even I cannot say small issues because they are very important issues, can be largely important for one's theoretical thinking. Questions are open. Yes, Bella, please.
Thank you very much, Roberta. Very interesting. You mentioned that Tartini was a student of Calegari. So obviously they were working in the same capella, but is there any evidence that he was Calegari's student?
So this is a whole discourse about the matter of the school concept, and this is my main topic here in Rome, because there are different, this is a very important question. There are different concepts and different definitions of school. So on one hand, this is one direct or obvious question about these pupil-teacher relationships, but this is not enough. Then you have the matter of chapel organization, and it's the main part, for example, in defining the Roman school, and then Roman school in relation to the so-called Paduan school. And there are other definitions connecting intellectual history. So in this sense, my work at least not really focus on these pupil-teacher relationships, but try this so-called of history of ideas.
Mm-hmm. Thank you.
But it was a very important question. Thank you.
Thank you.
Some other comments, questions? If anyone else would like to add something, you can even later put it in chat group. But now for the end of the session, I give a word to Nate.
Thank you, Lucia, for guiding us through this morning session.